Alright, Lala, hopefully this will be your last video, in case everything ends up getting recorded here. But basically, this is what differentiation is. Differentiation is when you apply the formula that I told you, where you multiply the power of that particular x variable with itself and you subtract the power by 1. And in case if there's any multiple with x, for example, x is already being multiplied with something, let's say that multiple is a, then you multiply that power with a also. Then differentiation will be you multiply that power with a also, and then you subtract 1 from the power. A and n are just constants. So let's go back to this one again, because this is where I left you. So let's say I have over here with me y is equal to 10x raised to the power 2. Then dy by dx, which is also defined as the rate of change of y over the rate of change in x, which is the same thing as your gradient, which you found out by finding your rise over your run. These all are the same things. This is all the same thing. The only difference is when your function is non-linear, when your power of your function is greater than 1, the curvature changes. And because the curvature changes, it's not easy to find your m by y1 minus y2. And then you need to apply differentiation to find your dy by dx, because x is different at every point. And because x is different at every point, you first find an equation of the line, which for example can be anything, 2x, 3x, 4x, 5x, even at times it's like 2x squared, 3x squared, 4x squared, 5x squared. So you find an equation of the line, and let's say for this purpose the equation is ax raised ax. Then you put in your values of x into this and you find the gradient at each point of x. Okay, so this is what basically differentiation is. So you find a gradient, but because your function is non-linear, you have to do your dy by dx, which is the same thing as change in y over change in x, which is the same thing as m that we calculated for a straight line in order to give your gradient. So let's come back to our example. So when your x is equal to, let's say, 10x squared, y is equal to, sorry, your 10x squared. So your dy by dx would be, you multiply this value of x with x, but in this case x is being multiplied by 10, so this would become 20x. And as soon as you multiply your power of x with x, you subtract its power by 1. So this would become 20x, because 2 minus 1 is equal to 1. Alright? Now let's go through this again, because this concept is very important. Now when your line is a straight line, it is easier for you to find the gradient of that line, which is your change in y over your change in x. So your change in y would be here, your rise, and your change in x would be here, your run. And this would give you the gradient of the line, which is constant at any point, because the line is a straight line. So m is equal to a constant. However, situation becomes different when you have a curve. When you have a curve, the gradient of the line changes at every point because it is not a straight line. And when exactly do you have a curve? When you have a non-linear function. Your non-linear function is when the power of x is greater than 1. So for example, you have y is equal to x squared, x2, x3, x4, x5. In these instances, your power of x is greater than 1 So your function becomes non-linear. It's not a straight function. How do you find the gradient of the line in such cases? The way to do it is through calculus. And calculus is basically this formula that your dy by dx is, which is equal to your gradient, which is equal to your change in y over change in x, is basically equal to your, for example, if this is x is to power a, you bring a over here, you multiply a with that value, and then you at the same time you subtract, when you bring the value here, you subtract the numerator with 1. So you subtract this with 1, and this is your formula for finding your derivative. If your derivative, if your if your equation is already being multiplied with something, let's say a raised to the power a is equal to xn. For example, this is y is equal to 5x. This is what the equation is, where a is any constant. It can be 5, 6, 7, 8, 9, 10. This is any constant. And this is x raised to power n. Let's say x raised to power 2, where n is any power of x greater than 1. For example, 2, 3, 4, 5, 6, 7, 8, 9, 10. This here. So your derivative would be dy by dx, where you multiply n with a. So this becomes an, which is over here, if you look, it's the same thing, dy by dx. I multiply 2 with 5 and I get 10. And at the same time, when I multiply my power with x, I subtract this power with 1. So this would become 10x, and I subtract 2 with 1 and I get 1. So this is your formula basically for your derivative. This is a formula for finding your derivative. This is basically the result that I'm getting. This is just an example I'm showing you. Anything raised to power x is equal to x in itself. So this is basically the example that I'm showing you, that how when you take in some of the this is an example of how to apply this formula basically, right? But the intuition is the same as before, and that intuition is that when you have a curve, it is hard for you to find the gradient of this curve. So you derivate it with respect to x. And the way to derivate it is you multiply this with this and you subtract the power with 1 and you get this. So this is the gradient of the line. Now how do you use this information? At x, you put different values of x, you substitute different values of x over here to find the curve at that particular point. For example, at x is equal to 1, when I put the value of x over here, I'll find out the gradient at this point. At x is equal to 2, I'll put this value of x here. I'll find out the gradient at this point. At x is equal to 3, I'll put the value here and I'll find out the gradient of x at this point. This is basically differentiation. This is basically calculus. So Lala, you need to go through this, and what I want you to do is to solve these examples that he's done over here, which is basically the same thing that I've done. Multiply the power of x with x and then subtract it by 1, which is what he's done. He's multiplied x with 2 and then it becomes 6, and he subtracted by 1 and he gets 6 to the power x. Do these examples and then try doing this equation right here, and then once you're done with this part, you need to solve this entire thing yourself up till here. Then you'll come back to me and we'll go on how to find the derivative of an inverse function. Okay, Lala? So you need to solve these derivatives yourself. Solve this entire thing up till here, up till the do not panic part, and then we'll revise some of it, and then we'll get together to derive the inverse function.